Okay, for the following system, we're going to be determining the magnitude and direction for this system. We can see here this system has a 8 kilonewton horizontal force with a diagonal force of 10 kilonewtons at an angle of 60 degrees. The first step would be to draw a free body diagram so we can simplify this system even further and see what loads are acting upon it. So this block, which is used to represent the system, we can simplify that and draw a point which makes the representation easier to interpret. So we can see here from the point there's an 8 kilonewton horizontal force. And we then got a diagonal force of 10 kilonewtons, which is at an angle of 60 degrees. So the first step would be, we can see that this is at an angle. You wouldn't worry about that. We can simplify that even further. So we'll be resolving that in the X and Y direction. This is in order for us to get the X and Y components. So if we start off by doing the sum of the forces in the X direction equals, we can then see that in the X direction, if we do 10 cos 60, which is the first step, and then we look at the other side, which is 8, but as it's in the opposite direction, it would be a negative, so minus 8. If we do 10 cos 60 minus 8, that would be minus 3. Then we do the same for the Y direction. So sum of the forces in the Y direction equals, which would then be, instead of cos, would be sine 10 sine 60 plus 0 because there's no force acting down. So equals, that would equal 8.66. So that's fine. And then in order to work out the resultant force, there is a formula that you would use. So the resultant equals the sum of the forces in the X direction squared plus Fy squared. That would then give you the resultant force. So if I show my working out here, so if we do resultant equals Fx squared, which in our case would be minus 3 squared. Please do remember to include your brackets. Otherwise, when you type this into a calculator or any other system, you would get an invalid answer. So then we do the same Fy, which then would be 8.66 squared, which we worked out earlier. That would then give us an answer of 9.17 kilonewtons. For this particular problem, I've obviously purposely kept the units the same throughout, but be careful on different sort of problems that you may have issues with the units and may need to convert them, etc. So that's fine. And then we would then need to work out the direction. So we then worked out that in the resultant. So now we can start off by working out the direction. So to work out the direction, again, we've got a formula for that. So theta, which equals tan inverse tan minus 1. And then you do sum of the forces in the y direction over sum of the forces in the x direction. And then if we then do that and input the numbers into that formula, so if we go onto our calculator and do the inverse of tan, sum of the forces in the y direction, which we worked out, so that would be 8.66. And then that would then be over -3, which we worked out earlier. That would then give you a direction of 17.9 degrees. So that's how you determine the magnitude and direction of this following system. I shall be doing more examples in due course. I do hope that you've enjoyed my video. Please do like, comment, and subscribe. Take care and see you for another one.